So now we're going to show you how we prepare 1% agarose gel. First of all, we have the agarose over here. It's a purified polysaccharide from seaweed. In the cylinder I have some pre-measured buffer containing the electrolyte to transport the current. In the bottle we have 1 gram of agarose pre-weighed. In this tube we have ethidium bromide to mark the DNA. And then just to the right we have the mold for the gel. And notice it has rubber gaskets on each side, and this part here is actually mobile. And to the extreme right we have the gel tray and the comb. So now we're ready to set up the mold. So we need to take the gel support. It goes between the two gaskets. Then we slide one side over and then we lock it down. At this point it actually is a sealed unit. And then we need to notice that we have notches on the side of the gel support. So now the comb will rest in these notches over here. Goes down. So now we're ready to start our gel. I'll be transferring the buffer to the pre-weighed agarose. Okay, this will create a suspension. And to get a perfect gel we need to melt it. So mix. And to melt it we'll be using a microwave. Of course the cap goes on and make sure it fits loosely. And then we'll set up the microwave. Goes in. Check the cap. And then we'll do it for 1 minute to start the melting. And after 1 minute we will open the microwave, mix again to recreate the suspension, and then microwave again for about 35 seconds and we should have a perfect gel. Okay, the microwave has stopped. We need to put on a glove or a mitt. Snug fit. Okay. Then we're going to go in. Okay, just mix a bit. Okay, so now you can see it's a fairly cloudy solution, indicating that the agarose is hydrated but not melted. Then we go back in, and this time we'll do it for 40 seconds. Okay, so 40 seconds is over. As you can see, it's boiling. So it's good. What I'll do is the cap is not that hot. Okay. Now we need to mix a bit. Get rid of the energy that's trapped in the solution. At this point the agarose is too hot to cast. So what we do is we cool it with some water. The objective is to cool it to go from its boiling point of about 100 degrees Celsius down to about 65 degrees Celsius. 55 to 65 is a good range to be in. Then initially I cool it from the neck down. Now the objective is to starts to boil, release. You need to keep this area fairly hot, because when we cast the gel, if this is very cold, as we decant the agarose, it will start to gel as it goes across the glass. So now I'll just focus on cooling the bottom part of the gel. The water is fairly cold. Always stir with a bit of mixing. If you were to leave it this way, you get localized cooling, and this part would gel. And when that happens, you create create an agarose that actually has a different concentration, so the porosity will not be uniform. Okay, at this point it's fine. When you can hold it, then you have like a very hot sensation but not burning. We're all set. Now we're ready to add ethidium bromide to the gel and cast. Okay, so now we're ready to add the ethidium bromide. Let's pick it up. We're adding 5 microliters. When you add ethidium bromide or CyberSafe, doesn't matter, whichever you're using, make sure you immerse the tip, you expel, and you rinse the tip and swish it around a bit. Make sure that all the DNA marker is added, and at this point it's important to make sure that the tip goes to waste. Now, as you can see, it's not homogeneous. We need to mix. Okay, that should be good. And now before you cast, what you want to do is it's better not to have the comb in the mold. And then when you cast, you're going to a cold plate, so you want to be fairly efficient at casting. So you just add fairly fast. Not fast enough to cause splashing, and then turn to pick up the last drop. And then you take the comb and you sweep the surface. You sweep it away from the area in which you'll be creating the wells. The objective of sweeping is to get rid of any bubbles that might be on the surface, and sometimes you have a lint that gets caught somewhere, and you sweep it off, and then you rest the comb at this end, and then at this point you leave the gel aside until it's solid, and you'll notice it's solid when it's actually grayish, and then it's good to go. One of the first things we need, of course, is a gel. This one has been casted, and we'll dismantle it a bit later. We have the gel box over here, and just over here we have the power pack to give us a direct current. We'll take a closer look at the gel box. Let's lift it a bit. We have our negative pole, and we have a platinum wire inside the box. On this side we have the positive, and the same thing, we have a platinum wire in the box. At this point, these two wires are simply linked by air, so we could not run a current through it. Okay, so now we're ready to transfer the gel to the gel box. What you have to do is take the comb from both sides and make sure you lift, keep it vertical, and pull out. Amazingly, there we go. Then open up the mold. So now we can see the gel and its wells. And then when we put the gel into the electrophoresis box, we make sure we put the well toward the negative. And now it is good practice to actually pour your buffer over the wells initially to dislodge the air that can be trapped in the wells. And then you fill both troughs of the apparatus such that the liquid connects the two platinums, and your electrolytes will carry the current. Often you get air trapped below the support, the gel support. So what you need to do is to lift, get rid of the air, and then put it back down at an angle so you have no air trapped underneath the support. If you leave air underneath the support, it causes the support to float, and when you come to load your gel, your wells tend to move away from you. So at this point we're ready to load the sample and run the gel. Now we'll look at some samples. One of them is as is, the other one is ready for loading. The first one that you see here, the clear one, is a sample as you prepared, and at this point it has the same density as the buffer, And if you were to take this sample, put it into a well, it would very rapidly diffuse out of the well, and you would lose the sample. In the next one, it's an equivalent sample, but to it we've added the loading buffer. And when you add the loading buffer, you add three components. You're adding some of the bromophenol blue to act as an indicator of the mobility, and you add glycerol to change the density of the sample, and you also add a bit of the buffer itself, so you maintain the electrolyte concentration. So this sample over here now has a greater density than the buffer that's within the well, and therefore when you add it, it will sink to the bottom of the well and will stay there for an amount of time. Okay, so now we're ready to load the sample, so we'll take up the sample. In this demonstration we'll load 10 microliters. One key step in loading is to clean the outside, and it's good practice to rinse the tip on the positive side because everything runs to red. And then we choose a well. We stabilize by actually touching the support. I guess extend the index, stabilize the pipettor on the index, align with the well, and then enter into the mouth and add the sample slowly. You add slowly to allow the liquid to, because your sample has a higher density, will sink to the bottom. When you reach the first stage, you keep it there. You don't use the second stage because you'll be injecting air, and then you withdraw. The first step is to stabilize, and what I like to do is actually rest my hand on the gel box, extend the index, and rest the pipette on the index for stability. Then I choose a well, a line, and I want to be at about the midpoint. Then I touch the liquid, and as I touch the liquid, we're essentially in the mouth, and then you add slowly. That's imperative. And then withdraw. Okay, so now we're going to load a sample, and for loading sample you need some stability. You choose a well. When you touch the liquid, you're essentially in the mouth of the well, and then you need to add slowly, because remember the sample has a higher density than your buffer. You should sink to the bottom of your well and displace the solution within the well. You do not use the second stage because you'll be injecting air, causing turbulence and mixing. You keep the piston compressed and you withdraw.